Hello, everyone. Thank you very much for joining today's webcast, AI with AWS. So my name is Scott Stieritz, and I'm joined by my colleague, Charlie Kirby. We're both business intelligence and analytics consultants at Thorogood, and today we're presenting this webcast from our Philadelphia office. A quick overview of what we're going to cover today, only a couple items on the agenda. A very, very brief introduction to Thorogood for people who aren't familiar with who we are. Then my colleague Charlie is going to take us through kind of an introduction to AI, and then I'll go through some of the specific AI offerings that are available through Amazon Web Services. And lastly, we'll wrap up with a couple of thoughts around what we should keep in mind as we get started with some of these services. So a very quick introduction for those of you who don't know Thorogood. We are an independent professional services consulting firm, and we specialize only in business intelligence and analytics solutions. So we operate as a single organization, but work with customers globally, and we have leveraged teams of consultants that draw from our offices around the world, such as New York, Philadelphia, and Sao Paulo in the Americas region, and then London, Bangalore, and Singapore as well. All of our consultants throughout the company are recruited and trained in the same way to develop a unique mix of skills. We blend business understanding, technical aptitude, and a deep understanding of analytics tools and techniques. We offer a full range of services, anything from BI strategy and roadmaps to maybe some recommendations around architecture and architectural design, solution design, end-to-end implementation, and then data services and support for production applications. And we've also seen a lot of success in supporting our customers with user training and user empowerment programs. As far as who we work with, typically our clients tend to fall into one of four data-rich verticals, which are consumer goods, pharmaceutical and health services, banking, and insurance. Our clients are some of the leading organizations in these sectors. We take a lot of pride not only in the clients that we work with, but also in the long-standing relationships that we've fostered with many of the names that you see on the screen. So now in terms of technologies that we work with, like I mentioned a minute ago, we're an independent consulting firm, so we don't align with one specific technology in particular. Instead, we work with and partner with many of the major players in the BI and analytics market. This is across back-end, front-end, and some analytics-driven technologies. So we've been working with several customers across a number of these different technologies. We're drawing upon primarily our experience through the AWS platform and some projects we've worked on in that platform for the discussion today. And what we kind of like to emphasize is that our independence means that we're able to develop well-rounded expertise and kind of recommend things for customers that make the most sense for your specific situation rather than focusing too much on one technology in particular. So after that quick introduction, I will hand it over to my colleague Charlie, who will take us through a little bit of an introduction to AI.
Artificial intelligence is a nebulous concept, and it can really refer to a number of philosophies that all feed into a central definition. For the rest of this discussion, we'll use this following definition for AI. AI is a simulation of intelligent behavior in computers. In practice, this means machine activity programmed to mimic cognitive functions such as learning, pattern recognition, problem solving, and more. Other terms related to AI often muddy the waters and can make this concept a little bit more difficult to understand. Machine learning, for example, is often misunderstood as an alternative to AI when it is actually a subfield of AI, and is currently the most prominent philosophical approach to simulating intelligent behavior. Using algorithms and statistical models that outline relevant features, a task can be completed without explicit step-by-step instructions. Deep learning is a specialized form of machine learning where a series of algorithms are given raw data and a task to perform, but the algorithm learns how to identify successes on its own. But why are we discussing these definitions? It is important to understand these definitions as the intentions of these philosophies are important to know before we try to apply them. These definitions are important to gain a baseline understanding before you start learning about the practical application of AI. But before we move into problem solving with AI, it is also important to move away from the definitions and discuss why you should care about all of this. To elaborate on this point, think of where you should be focusing when considering what AI might do for you. If our goal is to bring value, how do you set yourself up for value generation? First, have a target state vision. Where do you want to be improving in the short term? What changes would you address in the long term? Consider what is hindering your movement from where you are now to where you want to be. Next, consider what is driving the business value of AI adoption. What will you need to make the AI investment a valuable one? The 4 key factors of adopting any new technology are people, data, tools, and processes. You'll need to consider each one before deciding what in your process could be aided most by the adoption of artificial intelligence. Finally, briefly consider the path to further improvement. You'll want to strike a balance between generating value quickly and enabling further scalability. So what problems does AI solve? The first step in developing an AI solution is to understand what would drive your need for AI adoption in the first place. What drives this need is the concept that building an AI solution fundamentally is trying to replace humans in parts of the decision-making cycle that might be relevant to you. But why replace humans? The first major advantage of AI is to create consistency. Removing humans removes human error, so easily repeatable tasks like data entry, calculations, etc. are performed exactly as commanded every time. Consistency also means the consistency of decision-making. By algorithmically making decisions, there becomes a traceable reason why each decision was made, enhancing reliability and transparency. Humans, beyond having consistency issues, also have a hard time scaling their responsibilities to meet the demands of large data sets or other inputs. AI, on the other hand, can quickly work through enormous data sets without using the quality of outputs. Combining these 2 aspects, AI has a distinct advantage over humans in many strategic capabilities. And let's consider the decision-making process itself. It's also known as the scientific method, the iterative design process, or otherwise, but the base structure always looks something like this. Identify the problem, collect information, identify solutions, make your decision based on this evidence, implement, and evaluate. And of course, you can repeat this as many times as desired. For each of these steps in the process, AI can offer consistent and scalable improvements over a human in the same role. For example, when identifying a solution, a human may use their personal experience and the recommendations of others to highlight a few solutions they are aware of. Different people would generate different solutions based on their experience and disposition, which might be narrow or influenced by exogenous factors. AI, on the other hand, can remove this uncertainty by identifying every solution that is mathematically possible. So it can do it relatively quickly, enabling a complete view of the decisions that could be made. While a human may only identify what they think is most relevant, there may be other solutions ignored by a person that an algorithm would identify. Later in the process, like when a person typically is used to evaluate the results, AI can also have a role. At first, it might be necessary to keep a human in an evaluation role, as they can see if the results generated are within reason. But over time, you can train the model to identify success the same way the individual did, by using human input as what success was and was not. The model can learn on its own how to evaluate its own success. This would offer more rapid iterations, and with more iterations comes more accuracy. Now that we've seen the general approach to the problems that AI solves, let's discuss a more detailed view of what existing products use this methodology and solve these more concrete problems. To better illustrate these solutions AI may provide, it is important to understand some key terminology. The solutions here do not exist in a bubble. They are interrelated and may combine to form a solution that's relevant to you. We've discussed what machine learning is, but it is important to note that machine learning can be present in any product offering, as its methodology is very effective in many use cases. Deep learning, as mentioned earlier, involves a self-taught algorithm. With simple labeled inputs, deep learning can determine on its own how to recognize a pattern. In practice, deep learning can be implemented across fields, automating things like translations, object classification, image caption generation, and much more. Image recognition is the process to understand what is being shown in the image. Given a picture that a program has never seen, it can identify components of the picture and combine these insights to identify nuances that a human may not see. Natural language processing, or NLP, allows machines to determine what a person is saying, either by text or voice. Advanced programs can decipher speech across languages, and can even uncover the context and subtext within. An example of a business using this could be identifying what is being said on a call center support line, so you could track the effectiveness of your support. Speaking of support lines, this process can also be improved by chatbots. A chatbot is an automated program that interacts directly with users on your website, app, or elsewhere. This is helping solve simpler issues. While customer support lines are the most complicated application of these, There are certainly more uses to having these robust chatbots that are able to talk with many users and solve simple problems all at the same time. Data labeling, while sounding unimpressive, has broad implications that have many uses. This solution can reduce the time and effort that is needed to create a dataset and feed into other models. Through rapid data labeling, you can feed another machine learning algorithm with high confidence data, hastening your solution to the adoption process, as well as reducing time and cost effort needed to perform the task. The last solution we'll briefly look into is neural text-to-speech, which is what you hear from Alexa and other similar product offerings. Through use of a neural network, which essentially incorporates deep learning fundamentals with NLP, machines can deliver human-like communication with those it interacts with. A business could use this to improve external communications by creating content quickly that is tailored to a vast array of languages and sounds just as if you were having a discussion with a real individual. There are many more solutions that may be relevant to you. But what is most important to keep your priorities aligned? First, look at these considerations. Are you considering the potential users? Keep stakeholders involved throughout the process as you begin to design your platform. Is your data aligned to undertake such a process? What can you use to improve your data sets and get more effective results? Is the business case your top priority? The technology should not drive the solution. The problem should drive the solution. Now let's think of some everyday cases of AI. You may be thinking, how are these capabilities relevant to any business case? They may seem advanced for everyday use, so how does it help you? Consider how we interact with AI in our daily lives. There are many AI strategies being used to help businesses in ways you may not realize. For example, as you see here, when you're logging in somewhere and you have to prove you're not a robot, you're actually helping a machine learning algorithm identify images of text and read it with greater accuracy. If you've ever been looking up a product or service and then see that same product or something closely related in your Facebook recommended ads, this isn't because someone told Facebook to sell it to you. It is because Facebook has an advanced algorithm that gives each user ads that are relevant to them based on data they've collected on your Facebook page, your search history, and many other sources. Even talking to Alexa is a powerful use of natural language processing. Alexa can listen to your full sentences and answer questions, provide recommendations, or even perform tasks for you like buying products, sending somebody a text, or managing your daily calendar. Only by listening to massive amounts of natural language can Alexa understand and deliver what you need, and this process is constantly improving in its understanding. These have been implemented across businesses to improve their processes. You can improve your processes as well, provided your problem is one addressed by the functionality of an AI service. For the rest of this presentation, we'll discuss the AI product offerings of AWS, giving examples of how they're used and how they might be relevant to you. I'll pass it back to Scott, who will get you started with how you can improve your business today.
So as Charlie mentioned, we'll now kind of take a look at the AI and some of the ML offerings available to us through the AWS platform. So I figured a good place to start to kind of understand the AI landscape within AWS is with a very high-level overview of AWS offerings as a whole. So we can see that there are tons of categories of services. There's everything from data querying and analysis to storage and organization to cloud migration, platform monitoring and management, tons of other offerings. So a lot that's kind of available here. And today we're looking at AI and ML offerings, which for the purpose of this visual fall under the machine learning category. So within that AI and ML space, we can take a look at some of the offerings from AWS. And it's almost a little bit overwhelming as far as the technologies available and what they could be used for. And we could, try to tie some of these back to the visual that Charlie used earlier, but oftentimes, we might find ourselves focusing too much on defining the edge cases. Is something deep learning or is it technically machine learning under that definition? And as Charlie mentioned earlier, we probably shouldn't concern ourselves too much with the specific, nominal categorization of these. We should instead be thinking about what the services offer and why we may take advantage of these specific offerings. So when we think about the offerings in this way, the what and the why, we're kind of led to three main categories of AI and ML offerings from AWS. So one is AI services, the second is ML services, and the third is ML frameworks. So let's start with AI services. What exactly are they? Well, they're pre-trained services that are primarily drawing upon the intelligent models that actually are used to drive Amazon.com's business today. So Amazon's taken those models and really exposed them to you via APIs so that you can easily integrate them into your applications. They offer a number of different services, from recommendations to chatbots to image recognition, a lot of the things that Charlie kind of touched on a minute or two ago. Well, why might we want to use these? Well, first of all, they allow for rapid experimentation and rapid realization of business value. So you can get these very intelligent services quickly integrated into applications without any model building or really without any data science investment at all from your specific team. And they're built to be flexible and to work with your existing applications, meaning you don't need to build something from scratch within the AWS architecture just to take advantage of these services. As far as some of the offerings available, we can see the offerings that are available just to date on the screen, and this list continues to grow. So there's all the services that I mentioned before, plus a number of more services. Some of the interesting ones in particular are forecasting. So as opposed to kind of some normal forecasting methods that might take a look at one single time series or might look at one set of lagged variables that can only predict out one period into the future. Instead, this forecasting algorithm that, as I said, kind of drives Amazon.com's business, it's able to incorporate thousands of explanatory time series into a single target series prediction and can gracefully handle some complexities that would otherwise be tough to handle in time series analysis, like cold start data where we don't have time series that perfectly line up, or if we have some non-serial data where we just have a point-in-time capture of a number of variables. Those things can all be integrated into a single forecast. There's also some interesting developments that are now in preview, kind of at the bottom of the screen, these fraud detection and code offerings. So the code one in particular is actually a service that will review your own custom coding for you and identify areas in which your scripts can be made more efficient. So clearly a number of interesting things that are kind of on the pipeline here coming from AWS. The second category that we have are ML services. So as opposed to AI services, what are ML services? Well, pretty broadly, they fall under the offering of Amazon SageMaker. And this is a fully managed service that's focused on the ML lifecycle, effectively building, training, and deploying ML models. There's also a number of surrounding services that are part of this broad offering that can help with labeling training data to get started on model building more quickly. You can select from a large list of pre-built models if you're looking to do like a proof of concept. And again, it kind of abstracts us a bit from spending weeks or potentially more developing a model for which value hasn't even been proven yet. But on top of that, it also offers more flexibility than what we saw in AI services. It can do a lot more in terms of what we normally think of as ML development, like custom development and training of models. But what's managed about this offering is the platform itself. So we can have a flexible compute environment that runs these analyses, which can scale up and scale down to match the requirements of the specific algorithms or specific analyses that we're running. So why should we be interested? It just gives us a bit more flexibility than the AI services. We're not limited just to the service that's predefined by Amazon. It also offers us a bit of a pipeline feel, so it's not just a one-time integration of a model into an application or deployment as a service. We kind of always need to assume that these models will continually be retrained, occasionally redefined or improved, maybe as we discover some more accurate methods to kind of go about the same things that we were doing before, and therefore redeployed. So SageMaker allows us to do this pretty seamlessly. And then there's some specific SageMaker offerings, kind of those services surrounding that ML platform shown on the screen here. So that last category that I mentioned is ML frameworks, which broadly incorporates actual machine learning frameworks and kind of the underlying infrastructure. So lastly, what is this category? Well, we saw through AI services that there's basically no machine learning development required, just consuming pre-built services. Then through ML services, we saw a bit more flexibility, kind of a bring your own algorithm type situation, but using a managed platform. Then if we want even more customizability than what's offered to us through either of those categories above, we lastly have this ML frameworks category. So we can use AWS deep learning AMIs or Amazon machine images or deep learning containers, which have the newest version of common ML technologies installed, but there's really no real requirements as to how you use them, how they fit together into your development experience, what you go on to customize even further or custom install, anything like that. So why would you do this? It's really looking for maximum customizability. Some people like the feel of a single machine on which they can do a lot of development. Others could use this, especially some of the container images, as kind of a final step in the deployment process after a model is thoroughly vetted and tested and ready for production. And it kind of allows stripping down the environment to only the pieces of software and hardware that are explicitly required for serving that model. So I'm showing on the screen a couple of frameworks that are currently supported, and this list, again, continues to grow, but with the expectation of under ML frameworks that things can be custom installed on those machines or within those containers sort of as needed, depending on your specific use case. So now that we've reviewed the AI offerings available through AWS, we figured it'd be interesting to just take a quick look at one in action. So just as an example of what some of the services can do, and this isn't all that they can do, this is just a very light touch example. I created a slide with some sample text. I also pasted in a screenshot of a table with a bit of sample information, in this case about the webcast itself. I intentionally knocked the image a bit off kilter. A screen like this might look familiar to anyone who feels like you can never get a scanner to read in the document perfectly straight. So I've actually taken this slide and saved it as a separate PDF. Maybe let's consider someone who might need the information off a PDF like this, like someone in HR that's trying to review or automate the review of resumes, or someone who's looking at hand-filled in forms, maybe looking at incident reports in the insurance industry while assessing claims, something like that. Either way, it's important for us to get the actual data out of this PDF so that it can be read programmatically. Then we can benefit from the scale and consistency of further AI and ML approaches on top of this data, as Charlie mentioned earlier. So since I wanted to grab this data from an otherwise probably relatively computer-unfriendly PDF, we're going to jump over to Amazon Textract, which is one of the AI services for doing this exact same thing. So for the purpose of this demo, I'm just going to use the console interface for the service, but we'd theoretically probably integrate this functionality into another application via the APIs in real life. If I bring this onto the screen here, you should see the Amazon Textract console. So since we're a little bit short on time here, I won't show actually uploading the document, but this is the PDF that I've uploaded, and you can see that it goes through and it's pulling out each piece of information and pasting it in this raw text. But on top of that, it's kind of identifying, using actually some deep learning techniques, identifying some patterns on the screen. So this sort of off-kilter, sometimes shaded-in table, it's still able to recognize that as potentially a form that somebody's filling out, where it's auto, I haven't done any customization of this at all. I've simply uploaded one document, and that's it. And it's already associating Scott as first name, Stieritz, my last name, as the last name. So, it's already creating these key value pairs and even creating tables that you can feed into, other applications. And then we can actually download the outputs of this. So we could download the raw text. Maybe we want to parse that raw text using a custom parser. We can also get a bunch of information from the API response, like where we can see a line of text. We can see the AI service's confidence in how sure it is that that is indeed the line of text, that sort of thing. So a ton of information that's available here, and we could kind of use to move on to some other applications. Then lastly, it also allows us to export actual key value pairs. So we could take this, save it as a CSV, or have it auto-downloaded, something like that, and incorporate it into another application, or more likely, just send that file back as a response to the API call and incorporate this information downstream. So again, what we just saw there is I spent no time programming. I didn't need any machine learning knowledge whatsoever. I can just consume those intelligent services available through AWS. So now that we have that base understanding of the technical possibilities available to us in the realm of AI through AWS, let's kind of wrap up with some things to keep in mind as we get started with these technologies. So we've noticed some common challenges and some corresponding considerations on some initiatives related to AI and ML that we've been a part of thus far. One is data availability, so understanding not only the investment for acquiring data, but also labeling that data. So there are services available through SageMaker, such as Ground Truth, where we can actually outsource the labeling of that data depending on what some of those data sets are. We also want to make sure we have the right people involved in conversations to make sure that the right data relationships are used, data integrity is maintained, that sort of thing. We also want sound data governance practices to ensure that any of this data that's being used in the analyses or maybe sent to these services, anything like that, is ingested and handled and stored in an appropriate and safe way. We also want to make sure we have the right blend of skills. So I'm not only talking about model creation, not only the pure machine learning or data science aspect, but also deployment and productionization. So a pretty common challenge that we hear people run into is that they can get pretty quickly to a model, but then taking those final steps for productionizing that model is where they run into some issues. But really the AI and ML investment is only actualized when that model is available for the business to use. So it's kind of crucial to make sure that there's the right blend of skills between that ML side and then kind of the additional steps that need to get us all the way through productionization. So some organizations may have mature data science teams that are looking just to be empowered with some modern tools. Others may not really have mature teams quite yet and would want to take advantage of some of these kind of no ML knowledge required offerings like the AI services, autopilot through SageMaker, pre-built solutions in the AWS marketplace, that sort of thing. This allows quick experimentation and using sort of the experiences through that experimentation to drive what skills should be needed for the business rather than making a big investment up front and then figuring out what areas you need some skills in. A third consideration is time to value. So this one I think should be pretty obvious from the example I just walked through, but you can start pretty quickly with some simpler analyses as a proof of concept to get sort of an initial measurement of expected business value. You want to reassess this early and often, especially at decision points for whether or not you're going to make an analysis more complex, anything like that. There's pre-built models in SageMaker, like I mentioned, or the managed AI services, where we can understand value before exploring customization, and then we can kind of take some additional steps down the route of customization in SageMaker or in the deep learning AMIs if we so choose. As far as technology, some of these offerings, or even if we implemented some of these things on-prem, it can be expensive, especially for complex analyses where the compute requirements are pretty massive. So it's important to understand the technologies, understand what they're capable of doing, and some of the drawbacks to make sure that we're designing our architecture efficiently. We want to strike a balance between freedom and exploration and kind of a cost consciousness where we're doing some analysis and some thinking before going ahead and implementing whatever we want to implement. And also in terms of technology, this kind of offers us the pipeline for repeated analysis and continued improvement of an ML or an AI approach that I mentioned before. Then kind of the last point that I wanted to mention is driving adoption. So we found that it can be pretty challenging for business decision makers to blindly trust AI or ML approaches to solving problems, especially before some of these forward-looking solutions, before the accuracy of those are proven, since we kind of need to wait until the future for the accuracy to be proven. So instead, we can consider a phased approach, maybe where we have a parallel run of this approach going on with maybe the more human-focused traditional approach, or we could use something like Amazon Augmented AI, which actually keeps humans in the loop. So it's a framework for human auditing, human review when confidence falls below a certain threshold, something like that. So it's closely integrated with the other AWS offerings, and can kind of help us build some trust in the solutions before necessarily chopping off the existing solution and forcing everybody to try to trust a new AI approach. Our contact info is on the screen in case you have any questions or comments. Other than that, thank you all very much for joining, and enjoy the rest of your day.